Hello friends, we will be covering meter bridge equipment. In this, again, we are going to have the introduction, principle, working, usage, and a video just for you to understand it better. Coming on to the introduction first, a device to measure resistance. In lab, you might do this activity to calculate resistance of wire. Principle, it works on the principle of Wheatstone Bridge. This is the Wheatstone Bridge in which when bridge is balanced, P by Q equals to R by S. So when the bridge is balanced, P by Q equals to R by S. If the resistance of 3 wire is known, to calculate the fourth wire resistance, then we mathematically equate these and get the value for the fourth wire that we are not aware of. So material for construction will be wooden board, wire, unknown resistance wire, galvanometer, battery. The circuit diagram is shown here to you. This will be the complete length of this ruler will be say 100. Here this is a resistance that we are known to us R, and we are trying to find the resistance of this point say S. We are trying to find the resistance of this wire S. So we are going to make it in a balanced form. So how we are going to do that? One of the wire resistance R is known and one is unknown. We have connected B to a wire and galvanometer. So this point we have connected it further to a galvanometer, and then to this wire is going to be further connected down, and we are going to move this wire on the meter scale, which will be touched to a meter scale during the experiment. We prefer to obtain the balance point in the middle of the meter bridge wire to increase the sensitivity of measurement. So why do we need the point in the center? We need the point generally to be in the center because we prefer it that way. The balance point in the middle of the meter bridge wire to increase the sensitivity of the measurement. So sometimes this question is asked, why do we place it in the center? We can balance it down in the ends. What does it mean by balance? By balance, it means there will be no deflection in the galvanometer. Now looking at the working, current is allowed to flow from cell E. Okay, this is the cell E. The current is allowed to flow from here. A suitable resistance R is inserted from jockey, is gently slided over the bridge. So this is where the first resistance is, and then this is connected with B point galvanometer, and this jockey is slided over the bridge wire, and its position is adjusted at B, say to length L, from the end A of bridge wire till galvanometer gives no deflection, and that is when balance point is obtained. So at this point there is no deflection being shown in the galvanometer. So according to the Wheatstone Bridge, when the balance condition is formed, then R by X will be equal to, one is the resistance which is known resistance, one is the unknown resistance, will be equal to L by 100 minus L. So 100 is the total length of the complete scale, the ruler, and this will be 100 minus L. L is the point where there is no deflection being seen. So unknown resistance X can be derived by this formula. There are few facts which you can also learn. These are facts which I'm just reading it out to you. A meter bridge is a practical form of Wheatstone bridge. The connection between the resistor in a meter bridge are made of thick copper strips. Why are they made in thick copper strips? To ensure that the resistance of these connection is negligible. So we are trying to avoid the resistance. So resistance by these are negligible. That is why we are using copper strips as compared to those of the resistors. We prefer to obtain the balance point in the middle of the meter bridge. So why do we prefer the point in the middle of the meter bridge? Because it increases the sensitivity of measurement. A Wheatstone bridge is most precise when all the four resistance are equal value. All the four are of the equal value. The meter bridge will give accurate result when balance is obtained at the center of the bridge wire. We prefer manganese material because its resistivity is quite high. We have to take few precautions. What are the precautions? All connections should be clean. There should be no air or oxide. Calculate adjust so that there is zero error in the instrument. We take few observations. We swap the wires of known and unknown resistance to check any instrument error. So why do we swap the wires at times? We swap the wire. If this is a known wire which is here, say this is a known wire here and this is an unknown, we sometimes swap this here and put this here so that we check there is no error in the instrument. Now let us look at this video. This will help you to clarify the practical way, practical form, and this is free, available on the YouTube by Amrita University. So you can have a look here. This is one which is known to them, the wire resistance. It's a thin wire. The resistance of this wire is known. This wire resistance is unknown, which is the which we are trying to calculate. This is the ruler that has got the length in total 100. Once we connect this point with the help of a galvanometer and we move it on this particular scale, so we notice the point at which there is no deviation in the galvanometer, the needle of the galvanometer is not moving. That is the point we are going to use the formula P by Q equals to R by S. And where is this formula coming from? Wheatstone Bridge. So if three values are known, the fourth value can be calculated by this mathematical formula. So let's run this video and see. See, this is how they are connecting it. This is the ruler, the board on which the ruler is kept. This is the ruler. Here, this is the resistance that they have connected. So this is the resistance that is known. This wire, they are trying to calculate the resistivity which they are not aware of. Once they are connected, look at the knobs, how they are connecting it, the wires. Then here we are taking a wire through the galvanometer, putting it, we are going to connect it with the help, this is the galvanometer being connected, and this galvanometer all the way we are going to put the key here and place it. He's placing it and testing where the deflection in the galvanometer is 0 will be our point key. So we are measuring it on the scale. So with the help, he's moving the jockey, and once we reach at a point, say 48, so 100 L will be 48, and what will be the other distance? It will be 100 minus 48. The deflection has to be 0 at that point. So this is a practical form and practical example, and I suggest that you must see this clip. Okay, and we can swap it also. Why do we swap it? Tell me, to find out if there is any error in the instrument. So we find out that value as well. So you will be doing this in your practical lab in classroom. I hope this was helpful to you. Thank you.